Hello everyone, welcome to Physics is Fun. This is in continuation to what we studied in the previous video, friction core concept. So there we studied the condition for a block to slide. Now if you have not seen that particular video on friction core concept, I will request you all to go and see that video at first. Then things will be more clear. So for this block to just start sliding, this alpha is equals to phi max. What is phi max? The angle of friction. Now today's problem is this particular problem. There is a block and this block is lying on the floor. The coefficient of friction between the block and the floor is mu. You have applied an external force. What should be the value of this force? What should be the minimum value of this external force so that this block just starts sliding? That's the question. What is the minimum value of this external force so that this block just starts sliding? Now we have already seen that in order that the block just starts sliding, when the block just starts sliding, then maximum value of static friction is this. Normal reaction is this. This is the contact force. The angle between contact force and normal reaction is the angle of friction. So basically the resultant force, this resultant force is the resultant of which forces? The weight of the block mg and the external force which has been applied. So basically the resultant force has to be in this direction. So if I just zoom into it, I can say that somewhere this is mg, this one is mg, this is the resultant force, this should be the direction of resultant force. This angle is alpha. Now we want to minimize this external force. So basically vector sum of mg and f external is this fr. Now you see that I know that this will be the direction of fr, resultant force, but this is my mg. So external force is not necessarily a horizontal line. If it was a horizontal line, please tell me, is this the minimum distance? If I draw a horizontal line from here, is this the minimum distance between this line and this line? Never. So whenever we want to find the minimum distance between two lines, what do? We drop a perpendicular. So from mg, if I drop a perpendicular here, I can say that this is my f external. So this is mg plus f external vector, and that is providing me the resultant force fr. Please understand this. This f external can vary. This f external, it can vary either in this way or in this way. It can be like this, 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 like this, like this, it can be anything. But will it be minimum? This arrow's length is minimum only under this condition, when it is connected with this line at an angle of 90 degree. I am teaching you the simplest method to solve this problem. So this is 90 degree. And what is this alpha? This alpha is nothing but phi max. Now what is this phi max? Angle of friction. So can I say that sine phi max, or how can I relate these two? So sine phi max is f external by mg. So very clearly I can say that this f external by mg is sine phi max. F external is how much? mg sine phi max. What is sine phi? What is phi max? Angle of friction. Don't forget that. So angle of friction, what is angle of friction? Angle of friction is tan phi, na? And what is tan phi? So I am trying to figure out a triangle. You see, tan phi max, please see the core concept on friction. Tan phi max is equals to mu, right? So if I say that I have drawn a right angle triangle, it has got nothing to do with this problem. It is such pure geometry. See, if this is phi max, the tan phi is perpendicular by base. What is perpendicular? Mu. What is base? 1. So how much will this be? Right? So what is the minimum value of F external? So F external's minimum value is mg multiplied by sine phi max. And what is sine phi max? Perpendicular by hypotenuse. So I will put a mu here, and hypotenuse is root over mu square plus 1. So the minimum force which is required to be applied so that this particular block just starts sliding is this, mu mg by square root of mu square plus 1. So basically we have hardly used anything in this problem. One very simple concept, that this resultant force is the vector sum of mg and F external, and in order that this block just starts sliding, the question is the block just starts sliding, this alpha and phi max should be equal for just sliding. Remember this, alpha and phi max is equal. So Fr has to be in this direction, so resultant force must be in this direction, and this is mg. So F external, in order to be minimum, it can touch this line anywhere. It can be here, it can be here, it can be here, it can be there. But this is the minimum distance between this line and this line if we draw a perpendicular. Okay. So F external, in order to be minimum, must connect this line normally. So from here I can apply this simple concept and solve it using basic trigonometry. And this is the minimum force that is needed in order to just make this block slide. I hope this particular video has cleared some fundamental concept on friction. See you again in the next video. Thank you everyone, and have a good day.